This time-lapse of circular fisheye images is in fact mapped to equirectangular VR video. The stars are moving from east to west due to the Earth rotation. But this tracking time-lapse is created from the same source. You can see the landscape is now moving and the stars are stationary. Then average process is applied and now the color noise disappears. The averaging is actually stacking number of registered images, so the bit depth is increased. The tone is now stretched so the Milky Way is very clear. This stacked tone stretched time-lapse can be converted back to a video like fixed captured one. Hello. This video presents time-lapse movies of star tracking utilizing Python, opencv, and pyequilib module. Like the digest part presented previously, circular fisheye images can be converted to different tastes. I will explain a bit of what I do in the software. By the way, those are the related videos. The links to the videos are in the description, just in case you haven't checked them yet. First, I convert circular images to VR images using the same scheme that I explained in the related videos. I have added a function of adjusting the level so that the horizon looks flat. Then I expand the conversion program with software tracking feature. In Japan, the Polaris is always up in the north sky. The Earth rotation axis is pointing somewhere near the star. The moving rate is 360 degrees in 24 hours. The interval of the shutters is about 15.3 seconds with 15 seconds exposure in the burst mode of X-Pro1. The transform is to locate the Polaris at the apex. This would be the night sky seen at the North Pole. The star shifting direction is in horizontal, so every frame can be shifted back to the initial position. In the software, pyequilib module will do the all. I just need to specify the rotation angles of roll, pitch, and yaw. After I convert bunch of images with this software tracking, the time-lapse looks like this. The landscape is moving but the stars are stationary. Because the stars are at the same position in many frames, it's easy to stack them to remove the color noise in an averaging process. Now the image becomes so smooth. This is the averaged result of 32 frames. In the software, I actually sum up all the frame signals. That means I expand the JPEG's 8-bit color depth to 13-bit with 32 frames. In principle, I could expand 8-bit to 16-bit with 256 frames. Anyway, I added a function of storing the accumulated signal to a TIFF file. The saved TIFF files can be retouched in any Photoshop-like software. I use RawTherapee this time. The tone is capable of being stretched because I have extra bits in the darker regions. Milky Way gains its contrast now. After I apply the retouch profile to all TIFF files, a new time-lapse is created like this. The night sky is just like the one with long exposure photographs, but the landscape is moving. Then I realized that I could make a time-lapse like originally created. It means that the landscape is stationary because the camera is fixed on a tripod. The night sky is, however, like long exposure photos for the Milky Way's high contrast. The only trick is to set the Earth rotation compensation value to a -1. That means the whole spherical image is rotated backward with its center at the Polaris. Here is the final time-lapse video of the all conversions are done. Let's compare the original video and this one. This is the time-lapse of 15-second exposure frames. This is the tone stretched with 32 frames. The tone stretched might be overdone a bit. Anyway, this time-lapse is somewhat impossible with conventional photographing methods. Enjoy it a little more. The summer Milky Way is falling to the west horizon. The winter Milky Way is rising from the east horizon. Thank you very much for watching this video till the end. I will upload the 360 video itself separately. I hope the content is useful. See you next time.